Hi guys, welcome to Bancroft's weekly newscast. I'm your host, Iman Jalvin.
James Ormsby.
And I'm Ben Hughes. It's not really been weekly, has it?
Well, no, it's been about a month, but if we were on Mercury, this would have come out within the day, so actually we're ahead of schedule.
Ahead of schedule? Well, I mean, that's a first for any kind of project.
Well, speaking of Mercury, if you were there to see it, November the 11th, lasted for 5.5 hours, you would have been there looking at the sun, seeing a black spot appear from out of nowhere. Does anyone know what that is?
No idea.
Burn retinas? Well, eclipse. Everyone hears the sound of eclipse, you know that Mercury has passed straight through the line of sight in between Earth and the sun, causing a tiny, tiny black spot to occur.
So it's like a mini lunar eclipse.
A mini lunar eclipse. A mini lunar eclipse to the point that we know Mercury's so small it could fit in the Atlantic Ocean.
Wow. I mean, that's still pretty big.
Well, planet terms.
Okay, fair enough. While we're on the topic of space, scientists have found a new discovery in Mars in terms of oxygen. Stay with me, it's quite interesting. They've known for a while that, the carbon dioxide, water, that gets broken down by the sun releases oxygen. But what they found recently is that 30% more oxygen in spring and summer. And they don't know why. It might be to do with geographical reasons, which is boring. But, more importantly, it could be to do with microorganisms and their respiration patterns. And what does that mean, guys?
Life on Mars!
There we go. So, we'll have to wait and see, but it is very much a possibility. So, we'll update you when it comes.
Ooh, pretty riveting stuff, if I say so myself. But moving on with the idea of space. A group of researchers from Carnegie Mellon University have found a star which is moving 10 times quicker than anything in our galaxy. It is moving at a whopping 3.7 million miles per hour. And believe it or not, it's quite close to Earth.
I can't be good.
Oof. But don't worry too much. It's still 29,000 light years away.
Yeah. To be honest, I reckon I'd still have it in a 100-metre race.
Yeah, I'd back that too. You got to catch up with it. Well, I mean, if we're talking about fast, I mean, it's not exactly that speed. But our boys from Britain have managed to get our Bloodhound, the fastest land vehicle. They're trying to make it. They've got it to a new speed of 562 miles per hour. That's ridiculous. They're testing it at the lake bed of Hoxton Pan. It's been cleared of 16,000 tons of stone. Because if you're going at that kind of speed and you hit a rock and turn, and you're the driver, you're not going to like what happens
next. It's a rough bit of G-force right there.
Most definitely. The Bloodhound's fitted with a jet engine to keep it going as fast as possible, stabilisation fin to keep it nice and straight, and it's nice and aerodynamic with its thin, sleek body. They're trying to beat the world record of 760 miles per hour, which was broken in 1997, but eventually they're hoping to surpass 1,000 miles per hour.
Crazy stuff right there. Well, I mean, I think I've actually seen the Bloodhound.
Really?
It's actually so cool. I saw a model at a tech convention,
wow.
And it is probably the coolest thing you ever see. So if you're ever around and you have the ability to see it, I reckon you should go and see it.
Very futuristic.
Very, very futuristic.
Well, on the idea of futuristic technology, robotic insects have finally become wireless.
What?
Let that sink in.
It's like something out of Black Mirror.
Something out of Ant-Man.
Oh, that's for sure. But what does it being wireless actually mean? It means that when the bees, which we are currently killing with our greenhouse gas emissions,
Lovely stuff.
when they die out, we'll still be able to pollinate our crops, meaning that the human race won't die out just yet. Ben, you okay?
Ben, what's wrong?
Yeah, I'm sorry. I think my heart just skipped a beat of that amazing news.
Wait, your heart skipped a beat?
Yeah.
I know what you need.
What do I need?
Right? Researchers in Bath and Bristol have come up with an idea which uses the differences in the rate of the heart's beat.
Wow.
In a pacemaker. What does that mean? That means that the pacemaker is a biological pacemaker which can listen to the body's signals, therefore creating a specific beat to your body which makes your heart even more efficient.
Wow. That's going to save a lot of lives.
Revolutionary. 1.4 million people only survive from heart attacks.
That's quite a scary stat, actually. Well, we're done here, but we've got a special treat for you, lucky guys. We have our researcher out in the field, Arish Bothra. He's going to hit you with some special science news.
Arish,
see you later.
See ya.
over to you.
Hi guys, you join me out here in Sendai, Japan. We're going to be talking about something very important. You might be wondering why I'm out here, why I'm out in this beautiful environment. But sometimes things fall from the sky, such as meteors. And a very important molecule, ribose, which is the sugar needed for life, has been detected in such meteorites. Space rocks that fell to Earth contain ribose, an essential molecule for life's genetic machinery and other related sugars. The finding, reported online on November the 18th in Proceedings of the Natural Academy of Sciences, leads support to the idea that many of life's ingredients were delivered to Earth by interplanetary debris. Many organic molecules have been found in space. Comet Lovejoy, for example, carts around sugar and alcohol, are the base ingredients for a decent interplanetary cocktail. But until now, no one has confirmed an extraterrestrial source of ribose. This molecule forms part of the sugar phosphate backbone of RNA, which are molecular workhouses within cells responsible for reading and carrying out instructions of DNA. Yoshihara Furukawa, a geochemist in Tohoku University in Sendai, Japan, where I am right now, and colleagues found the ribose, along with several chemically similar sugars, in samples from 2 meteorites, one in Morocco, one in Australia. By measuring the amount of carbon-13 in the sugars, the team found that the compounds likely originated in space and weren't picked up on Earth. The team suspects that the sugars formed from chemical reactions between water and formaldehyde in the meteorites long ago. Previous lab work in the simulated space environment were also shown that ribose can form on interstellar ice grains. And another similar experiment has done the same for ribose's chemical cousin deoxyribose, which helps form the backbone of DNA. So next time you're out, just be aware of what's out there, the meteorites. They could be there, and you could find some ribose.